All right, everyone, let's dive straight into the amazing world of light. आज हम रोशनी के कुछ super interesting secrets को explore करने वाले हैं. We're going to see how it travels, how it bounces around, and how it creates all the images we see every single day.
You've definitely seen this, right? The super bright headlights of a train cutting through the dark. That light just shoots out and it looks like it's in a perfectly straight line. But have you ever really, stopped to think about it? Ye light ja kahan rahi hai? And how exactly does it get from the train to way out there? Well, it turns out the very first, most important rule about light is actually really simple. Light travels in a straight path. Let's see if we can prove it.
Okay, so check this out. It's a super simple experiment. On the left side, you see a boy trying to look at a candle through a pipe that's bent. Do you think he'll see anything? Usko kuch dikhega? No way. The path is totally blocked. But now look at the right side. With a straight pipe, boom, he can see the candle flame perfectly clear. This is such a simple but powerful proof.
Now, this idea, this property, it has a pretty big scientific-sounding name. Rectilinear propagation. I know, it sounds complicated, right? But it's just a fancy way of saying what we just saw. That light travels in straight lines. Simple hai na? Just remember, roshni hamesha ek seedhi line mein travel karti hai. So, we've established rule number 1. Light travels straight. But what if we want to change its direction? Is there any way to make light, take a turn? Let's find out.
And the answer is absolutely yes. We can change the path of light. And the secret is something you actually see all the time. It's the magic of reflection. तो ये reflection का जादू है क्या? Let's get into it. Do you remember that famous old story from the Panchatantra? The one about the really clever rabbit and the not-so-clever lion? The rabbit tricked the lion by showing him his own image in the water of a well. The lion sees it, thinks it's another lion, gets angry, jumps in, and, well, you know how that story ends.
What's so cool about this story is that the rabbit was basically a little physicist. Usne physics ka istemal kiya. He used the super calm water in the well just like a mirror to show the lion his own reflection. That other lion was nothing more than light bouncing off the water's surface. So what is reflection really? Well, when a beam of light hits something shiny or polished, could be a mirror, a steel spoon, or even perfectly still water, it bounces back. This change in direction, this whole act of light bouncing off a surface, that's what we call the reflection of light. Okay, so let's talk about the kind of mirror we all use every single day, the good old plane mirror. Chalo plane mirror se thodi masti karte hain. So I want you to think about this for a second. Jab aap mirror ke samne khade hote hain, is the image you're looking at exactly like you? There's one really interesting and kind of strange difference. Have you ever noticed what it is? You can try this right now. Go on, raise your right hand. Your reflection in the mirror raises its left hand. Weird, right? This strange little switcheroo of sides, where your right becomes left and your left becomes right, it actually has a name: lateral inversion. The image isn't upside down, no, but sides get swapped. And this isn't just some funny trick mirrors play. Check out this real-world, life-saving use for it. Why is the word ambulance always written backwards on the front of the vehicle? You guessed it. It's because of lateral inversion. This way, the driver in the car ahead sees it written the correct way in their rearview mirror and knows to give way immediately. Dekha? That's physics in action, saving lives. So, let's just quickly summarize the 3 big rules for a plane mirror. Number 1, the image is always erect, yani sidi. It's not upside down. 2, it's always the same size as the actual object. And 3, the image looks like it's just as far behind the mirror as the object really is in front of it. Those are the key things to remember. Okay, so plane mirrors are pretty simple, but things get a lot more interesting when mirrors aren't flat. Let's explore curved mirrors, and we can do it with something you can definitely find in your kitchen. Seriously, go grab a shiny steel spoon, ek chamach. Now, have a good look at your reflection in it. This simple, everyday spoon is a perfect example of a curved mirror. Actually, it's not just one, but 2 different types of curved mirrors all in one object. Okay, let's break this spoon down. The inner part of the spoon, right, the part that you'd scoop up soup with, it curves inwards. This side is a concave mirror. The easiest way to remember this is that it forms a little cave you can put things in. Now flip it over. The outer bulging side that curves outwards, that is a convex mirror. So remember, Concave is like a cave, and convex is the other side. All right, time to tackle a slightly trickier idea. It turns out, not all images that mirrors make are the same. There are two main types, real images and virtual images. You could almost think of them as asli or nakli images. Let's figure out what really makes them different.
So here's a question for you. If you take a plain piece of paper and hold it up, can you actually catch your reflection from a normal mirror on it? Go ahead and try it with your bathroom mirror. You'll find the answer is no. But what if we used a special kind of mirror? Now look at this. In this picture, someone is using a concave mirror to focus sunlight onto a piece of paper. You see that incredibly bright, sharp spot of light? That's not just random light. That is a real image of the sun. We've actually managed to project or catch the image on a screen. And that is the big secret. An image that you can actually form on a screen, like a piece of paper or a wall, is called a real image. Ye hai asli image because you can actually project it onto a real surface. And concave mirrors are special because they have this ability to form real images.
So what about the image in your bathroom mirror, the one that you can't catch on paper? Well, that is called a virtual image. You could call it the nakli image in a way because it only looks like it's behind the mirror. It isn't really there. So here's the bottom line. Real images can be projected onto a screen. Virtual images cannot.
So you might be thinking, okay, this is interesting, but why does it matter in real life? Well, it matters a lot. These principles are used everywhere. Dentists use a small concave mirror to get a big, magnified view of your teeth, and the shiny part inside a torch or a car headlight, that's a concave mirror too, designed to grab all the light from a tiny bulb and shoot it forward in a super powerful focused beam. Pretty useful, huh?
So today we learned a huge rule. Light travels in straight lines. And we saw the magic of how we can bend that path using reflection with all kinds of mirrors. Now that you know how it all works, here's my challenge for you. Just look around. In your house, on the street, where else can you spot these rules of reflection at work? Once you start looking, you'll see this science everywhere.